Hello. For this question, we have to solve for the molar enthalpy. So some key bits of information that I've written down here. I've written down the specific capacity of ice, of water. So ice I have 2.01 joules per gram Kelvin, and water 4.18 joules per gram Kelvin. The heat of fusion of water is 334 joules per gram, and the heat of vaporization of water 2,257 joules per gram. This vaporization just means that how much energy is required for water to turn into steam, and for heat fusion of water is how much energy is required for ice to turn into water. So in this question we have what amount of heat is required to convert 2.5 kilograms of ice at negative 15 degrees Celsius into water at 30 degrees Celsius. So first let's deal with ice. So the temperature change is negative 15 degrees Celsius to 0 degrees Celsius. So formula Q equals mc delta T. So for mass, we know that this is 2,500 grams because 2.5 kilograms times 1,000 gives us 2,500 grams. For ice, we've written down that it's 2.01 joules per gram Kelvin. And for the temperature, we have to convert everything into Kelvin, and 273.15 Kelvin is equal to 0 degrees Celsius. So what we have here, so the final temperature is 0 degrees Celsius, which is 273.15 minus T initial, which is negative 15 degrees Celsius. So converting that into Kelvin, you get 258.15 Kelvin. So after you plug this all in and solve, you should get 75,375 joules. So that's step one. Step two, we have to determine how much energy does it take for ice to turn into water at 0 degrees. Because at 0 degrees, the change of state also requires energy. So the formula that we're going to use is Q equals m delta heat of fusion. So Q equals m delta H. So in this case, we're going to have 2,500 grams times 334 joules per gram. And when you multiply this out, the grams will cancel out and you'll only be left with joules. So you should get 835,000 joules. The third step is to determine how much energy is required to increase the water temperature from 0 degrees to 30 degrees. So Q equals mc delta T. Q equals 2,500 grams. Water is 4.18 joules per gram Kelvin. And then T final, 30 degrees, convert that into Kelvin. So you get 303.15 minus 0 degrees. So that's going to be 273.15 Kelvin. When you plug this all in and solve, you will get 313,500 joules. So the fourth step, you're going to add it all together. So the total amount of joules is going to be 1,223,875 joules. And to solve for molar enthalpy, you need to determine how many moles of water you have. So mole of water, which is H2O. So the formula is mass is moles equals mass for molar mass. And the molar mass of water is 18.02 grams per mole. When you plug this in, you should get an answer of 138.73 moles. So the mole enthalpy, you're just going to divide the amount of joules, molar enthalpy. You will divide the joules by the moles, and you should get 8.82 kilojoules per mole.